I'm going to talk about an equation. Most of the chemical reactions are represented by an equation. An example of a chemical reaction is the reaction between hydrogen and oxygen that produces water. That's an example of a chemical reaction. Then the definition of an equation is that an equation is a chemical sentence that is describing what is going on in a chemical reaction. And the substances that takes part in a chemical reaction are referred to as the reactants. And the substances that are produced during the chemical reaction are referred to as the products. The reactants are written on the left side of the equation, and the products are written on the right side of the equation. So I'll give the general structure of an equation. So the general structure of an equation can be written as A plus B. So A plus B, when they react, will produce C plus D. So this is just the general structure of an equation. So A plus B, when they react, they produce C and D. So A and B here, they represent the reactants. This is because they are on the left side of the equation. And C and G, since they are on the right side of the equation, they can be referred to as the products. Then the other thing that you're supposed to know on this general equation is that the plus sign that is on the left side of the equation means react with. Then the arrow, it means produce. Then this plus sign on the right side of the equation, it means and. So this general equation can be read as A reacts with B to form C and D. So A reacts with B to form C and D. This is the general structure of an equation. So now I need to talk about an weight equation or weight equation. So a weight equation is a type of equation that is written using weights. So this is a very simple. This is a type of an equation that is very simple because it only involves weights. So an example of a weight equation is the reaction between hydrogen and oxygen to produce water, and its weight equation can be written in this form. So, hydrogen reacts with oxygen to produce water. So this is an example of the weight equation. The weight equation that involves hydrogen and oxygen to produce water. So you just write hydrogen plus water, they will produce what? Hydrogen plus oxygen, so they will produce water. Another example of a weight equation is if you have been told to write a weight equation between the reaction of calcium and water. So calcium has calcium plus water. So the reaction between calcium and water, their products will be calcium hydroxide plus hydrogen. So these are the two examples of the weight equations. The first one is the reaction between hydrogen and oxygen that produces water, and the second one is the reaction between calcium and water that produces calcium hydroxide plus hydrogen. So the weight equation is very simple because it only involves you writing the weights of the substances that are involved in that chemical reaction. The other thing that I'm going to talk about are state symbols. So state symbols, the state symbol is a letter or letters that are used to denote the physical state of the substance that is in an equation. So the state symbols, these are just letters, or it can be a letter that is used to denote the physical state of the substance that is in an equation. Then these state symbols, they are written as small letters in brackets, and they are written after writing that substance in an equation. When a substance is a solid, a small letter S is written after that substance, and when a substance is a liquid, L, a small letter L in brackets is written after that substance. Then when a substance is a gas, a small letter G in brackets is written after that substance. Then when a substance is dissolved, it is dissolved in water, and the letters AQ in brackets is written after that substance. So there are 4 types of state symbols. The first one I've said is the state symbol that can be used to denote a substance that is in solid form. The other state symbol is the state symbol that you can use to denote a substance that is in liquid form. The other state symbol is the state symbol that you use when a substance is in a gaseous form. Then the other state symbol that you can use is the state symbol that is used to denote the substance that is in aqueous form. So these state symbols can be written for solid. A small letter S is, a small letter S is written after that substance in an equation. Then when a substance is liquid, M is written after that substance in bracket. Then when a substance is in a gas form, G is written after that substance, and when substance is dissolved in water, AQ is written after that substance. AQ is written after that substance. Then AQ represents aqueous solution or an aqueous solution. The other thing that I'm going to talk about is a chemical equation. So a chemical equation is a type of equation that is written using the chemical symbols. So this guy is only written when you use the chemical symbols. Then the chemical equation it's not very simple. It is harder than the weight equation, because the weight equation it only involves weight, but the chemical equation it involves you writing down the equation using the chemical symbol. So an example of the chemical equation between the reaction of hydrogen and oxygen to produce water can be written in this form. So the chemical symbol of hydrogen is H2 plus oxygen to produce water, H2O. So this is the chemical equation between the reaction of hydrogen and oxygen to produce water. Then the physical state of hydrogen is gas, so the G will be used, and the physical symbol hydrogen is gas, so this will be used in the G. Then the physical state of hydrogen is in a gas form, so a G will be used as a state symbol. Then since this is water, an M will be used. Another example of a chemical equation that will give is the reaction between calcium and water that produces calcium hydroxide plus hydrogen. The gas, the state symbol of calcium is the state symbol of water is M, the state symbol of calcium hydroxide is AQ, then the state symbol of the hydrogen gas that is produced is G. The other thing that I'm going to talk about is how you can balance an equation. So when you're balancing an equation, first of all you need to count each atom on the left side of the equation and on the right side of the equation. And when that atom is balanced, you don't add any number. But if that atom is not balanced, you add a number in front of that atom so that you can make it balanced. So that you can make it balanced. So I'll give an example how you can balance a chemical equation between the reaction of hydrogen and oxygen that produces water. So the first thing that I'm supposed to do is to write the chemical equation of hydrogen and oxygen that produces water. So take for instance, I've been given this equation, then you've been told to balance it up. So the first step, you need to count each atom on the left side of the equation and on the right side of the equation. So our hydrogen here is 2. Then here our hydrogen is 2. So it means the hydrogen, it is balanced. We come to oxygen. Here oxygen is 2, here oxygen is 1. This means that oxygen is not balanced. For you to make oxygen become balanced, you add a 2 here. So here oxygen 2, here oxygen 2, which means oxygen is balanced. But here, these 2 multiplies with these 2, it will give hydrogen here 4, but hydrogen here 2, which means we need to add a 2 here for hydrogen to be balanced. So this equation has been balanced. Another example that I'll give, if you have been given this equation, the chemical equation that involves the reaction of calcium plus water. So if you have been told to balance up this equation that involves the reaction between calcium and water to produce calcium hydroxide plus hydrogen gas, you start first by counting. Here the number of calcium is 1, the number of calcium here is 1. So it means calcium it is balanced. The number of hydrogen here is 2, the number of hydrogen here it's 2 plus this 1, 2 plus 2 plus 2, this is because this 2 multiplies everything. So here we have 2 hydrogen atoms, we also have 2 hydrogen over oxygen. So here the number of hydrogen is 4 because we are going to add these 2 and these 2 of the hydrogen. Then this means that hydrogen is not balanced because here we have a 2, here we have a 4. Then for oxygen, here we have 1, here we have 2, which means oxygen is not balanced. For you to balance up this equation, just add the 2 here. So here hydrogen 4, here hydrogen 4. Here oxygen 2, here oxygen 2. Calcium here 1, calcium here 1. This means that this equation has become balanced. The other thing that I'm going to talk about is how you can write an ionic equation. So an ionic equation can be written by, first you need to write a balanced chemical equation with state symbols. So if you have been told to write the ionic equation between the reaction of calcium and water that produces calcium hydroxide plus hydrogen gas. So your first step, you need to write the balanced chemical equation of that reaction, including the state symbols. After you have done that, you separate the substances that are in aqueous form. If you separate the substances that are in aqueous form, then you write down your equation, and that equation will be an ionic equation. So I'll give an example between the reaction of calcium and water that produces calcium hydroxide plus hydrogen gas. So this is a balanced chemical equation between the reaction of calcium and water that produces calcium hydroxide plus hydrogen gas. So this is the first step. I've written this chemical equation and I've balanced it, and it also has the state symbols. Then the other thing that I've said, you need to separate the substances that are in aqueous form. So for this equation, the calcium is in solid form, so which means you don't separate this. I won't separate this element. Then water is in liquid form, so this means I won't separate water. This is because it is not in aqueous form. Then calcium hydroxide is in aqueous form, so I'll separate this calcium hydroxide because it is in aqueous form. And hydrogen here is in a gas form, and you don't separate the substance that is in gas form. So my ionic equation will be written in this form. Calcium, I'll just bring it down, and water, I'll just bring it down. Then I'll separate the calcium hydroxide. This is because it is in aqueous form. So I'll write calcium Ca. Then calcium has 2 electrons in its outermost shell, and for it to be stable, it needs to lose those 2 electrons. So I'll write plus. Then Aq, which means this calcium is in aqueous form, plus OH minus the valence of an hydroxide. The valence of hydroxide is a negative. Then I'll include Aq which means the hydroxide is in aqueous form plus hydrogen. I won't separate hydrogen because it is in a gas form. So this is how you can write the ionic equation between the reaction of calcium and oxygen, between the reaction of calcium and water, that produces calcium hydroxide plus hydrogen gas. The other thing that I'm going to talk about is how you can write down a net ionic equation. So the net ionic equation can be written by following these steps. So the first step, you write the balanced chemical equation including state symbols of that reaction or the reaction that you are given. Then the next step involves you writing down the ionic equation. After you write down the ionic equation, then you cancel out the substances that are in aqueous form, that are both common on the left side of the equation and that are common on the right side of the equation. So I'll give an example on how you can write a net ionic equation between the reaction of sodium hydroxide plus hydrochloric acid that produces sodium chloride. The reaction that I'm going to give is the reaction between sodium hydroxide plus hydrochloric acid that produces sodium chloride plus water. So this is a balanced chemical equation with state symbols of the reaction between calcium hydroxide plus hydrochloric acid that produces calcium chloride plus water. Then the next step, I need to write the ionic equation for this reaction. So this is the ionic equation of the reaction between sodium hydroxide plus hydrochloric acid that produces sodium chloride plus water. So you separate that. I've said when writing down an ionic equation, you only separate the substances that are in aqueous form. So the sodium hydroxide is in aqueous form. That's why I separated it. Then the hydroxide, the hydrochloric acid is also in aqueous form. That's why it has been separated. Then the sodium chloride is also in aqueous form. That's why it has been separated. Then the water since it's in liquid form, you don't separate anything that is in gas, liquid, or in solid form. Then the next step involves you cancelling out the substances that are both common on the left side of the equation and on the right side of the equation. So for my equation here, sodium is common, so I'll cancel this sodium and this one. Then I'll look for another substance that is common on the both sides of the equation. The chlorine ion is also common, so I'll cancel it out. Then the hydroxide ion and the hydrogen ion, these are not common on both sides of the equation. So I'll write down my net ionic equation as so here on the left side of the equation, I've just remained with hydroxide plus the hydrogen ion and on the right side of the equation, I've just remained with water. So this is the ionic equation that you can write between the reaction of sodium chloride, sodium hydroxide plus hydrochloric acid that produces sodium chloride plus water. So this is the ionic equation. So the hydroxide ion plus the hydrogen ion, they will produce water. This is the ionic equation. I hope you have understood on how you can write the chemical equation, how you can write the net equation, how you can balance up the equation, and the information on the state symbols. Thank you very much.